Hello, this is a tutorial to show you how I did my data analysis of ELISA test. However, I think you can apply most of these steps if you want to create your standard curve for different purposes. And then I will show you how I've done my data analysis on the GraphPad Prism. So to start with, you will have your plate reading. So these are the absorbance values from the plate reading. And in the first three columns here, I've got my standard concentration. So these concentration or these absorbance values, I know what the concentration of the material that they reflect. These absorbance values of my sample, I don't know. So what I will do is that I will plot standard curve using my absorbance values of the known concentration of the standard, and then I will use that plot to estimate the concentration of my sample of the specific material in my sample. So this is the point of doing this analysis or standard curve with ELISA. To start with, it depends on how you measured your absorbance values with the plate reader, but in some settings, the machine will automatically subtract the background values. Sometimes it doesn't. So in some cases, like this reading, so for example, this is my original reading, and the machine will take another reading of the background, and what you will need to do is to subtract your absorbance values. You need to subtract these background values, which is mostly will be zero values, from your um, actual plate reading to get your standard readings here. And sometimes you don't measure the machine doesn't give you a second measurement of the backgrounds. It depends how you set the readings. But in this case, you can still use these wells, the empty wells. So these wells only had a buffer in them, and they didn't have any concentration, any reagent, so they should serve as blank. So here I will have my blank, which is equal average of these three wells, and this should be my blank. And then I will try to subtract each cell. I will try to subtract the blank, the background. To make this easier, I will make the blank cell constant. So I can just drag it 5, 6, 7, 8. Yeah, and this should have the so this had my B9 minus B11. This had my C5 minus. So just to make sure that it is working. So these are the values that I will work on, which I have the background subtracted. So I will start with setting up the standard values, concentration that I know. And with this instance, I've used IL2. So this is plate reading of the amount of IL2 in my media. And the standard concentrations started with 1000 picogram, and then with continued with serial dilution. So what I did is diluted. So this equals this cell divided by 2, and so on. So these are my serial dilutions: 1000, 500, 250, 125, and so on until 15. This cell was empty, only buffer in there, so this is 0. And these are my noun concentrations. These 3 triplicates are the absorbance values. I will only insert paste as data to avoid any errors. Okay, and then I continue by plotting. I will start labeling my samples. So I know what my samples here, and it depends on your experience. You should be able to label your samples. So the first sample was my control. And I will symbol it with N, which is naive, and then an A. Let's give it 1 because this is my first experiment, and it is an A, nothing added. And then I've got my 1 for hours. So in this one I've added my treatment for 4 hours. The following one, still the first experiment, and in this one I've added my treatment for 6 hours. The last one will be 24 hours treatment, and I've done this about 5 times. I will just, because I've already done this here, so I will just copy paste them. And I've already organized my values, which are here in vertical order. Sorry, these are the subtracted values. Okay, all done. So I'm ready now to transfer my data into the GraphPad Prism. So let's open GraphPad Prism. And we need to choose type of sheets. We will use, for the standard curve plotting, we will choose XY. And we will have 3 replicates and create. Okay, so this is our sheet. We will start transferring our data. And we'll start by using our standard concentration into the X column. And then we transfer the absorbance values of the concentration that we know. So for this one, we know the concentration. We know that these are the absorbance values for 1,000 picogram, and these are the absorbance values for a 500, and these are the absorbance values for 250 picogram, and so on. So we can plot a standard curve according to these known informations. And then we will have our absorbance values for our samples, but we don't know how much IL-2 in our samples here. And that's why we are doing this. We want to find out. So we will move our label. so we know which is which, and click here. So this is our STD standard, and these are our OD readings. Okay, and now we will choose the symbol which says interpolate standard curve to plot a standard curve. You will have different options here. It depends on what you are doing, what exactly type of your data, what do you want to find out. But for this purpose today, we usually choose either second order polynomial or hyperbola. I'm not sure what's the difference between them, but it depends on how your data fits into the curve and what is the best curve for your data. So that's what I used, and it works for my data and gives me a good standard curve. The key is be consistent. So if you choose to use second order for your experiment, use it for all your experiments, just to be consistent. So we will create it, and here it is. So we will have a sheet where we will have the concentrations according to what. So we will go into the graph here, and this is the suggested created. This is my standard curve, and these are, so this is the 1000, this is the 500, this is the 250, and so on. These are the known concentration on the curve, and according to this, and according to the second order setting we choose, we will get these concentration to my samples. So you can see here the control is 0. The level is too low to be picked up. So control is 0, 4 hours is 30 picogram, 6 hours is 75, and the 24-hour is the highest, is about 500 picogram. So brilliant. I've got my standard curve, I've got my values, concentrations, and now I will move to try to analyze my data, and for the type of my data, because I have different experiments and each experiment have got different conditions, which are different times incubations with the treatment. So for this instance, I think I will use Way ANOVA. Okay. And so what we will do for the Way ANOVA, we will start by choosing a new file, a new data table and graphs. Okay, and this time we will use columns, not XY. We'll be fine with this. Create. Good. So the first column should be my control. The second should be my 4 hours, and then my 6 hours, then my 24 hours. And I will keep transferring my data copied. I've just copied, so I will just show you data into the new sheet. We will paste with transpose. So this is our first sample. Paste and transpose. My second experiment. My third collection of data, and I will skip this one just because I am missing two values, the control and the 24 hours. Probably this was too low and this was too high. Uh, I will use this because I have all the data sets. No transpose. Okay, and this is assuming it is too low, we will 0, 0. Control didn't produce any IL-2. Okay, so I have my calculated concentration according to the standard curves. I've fitted them into a new data sheet, and now I need to analyze them. So we will choose analyze. Or you can do t-test, one-way ANOVA. It depends on what type of analysis you are seeking, type of your experiment. So we will go for one-way ANOVA. We press OK. And then make sure you choose multiple conversion if you want to compare different values in different experiments. So compare the mean of each column with the mean of control, or compare the mean of each column with the mean of every other column. So everything against everything. I'm curious where I can find significance. So I will just choose multiple conversion. Okay, and here it is. You will have a summary of your p-value, good significant values. Multiple conversion can show you the list of multiple conversions that we did. So control versus 4 hours, I've got no significance, while control versus longer incubation 6 hours, I've got a good significant value. And the control against the 24 hours, I've got a higher significance, and so on. If you can see the graph, so I can go with a bar chart for that, and you still can draw your automatically add pairwise. I can just click and remove whatever I don't want. You can play with this graph. Basically, you can play with your labels, colors, significant bars, but here it is. I hope you find it helpful. Yeah, thank you.